Hello students, let us do the logic gates in Verilog style or using the Verilog programming skills by the help of Xilinx Vivado software. So what I will do here, I will write the Verilog code for logic gates like AND gate, OR gate, NAND gate, NOR gate, XOR, XNOR. Okay, and I will verify whether those gates are the code are correct or not by the help of a test bench. So we know that there will be three styles of modeling like structural or gate level modeling, data flow modeling, and behavioral types of modeling. So I will write the logic gates for all three types of modeling, and I will write a test bench. That test bench I will pass or I will give input to all those three types of modeling, and I will verify the output and check whether the output is correct or not. So let's start. Let's go to the Vivado software and see the code. Now see here, I have already written the code. This is the logic gates for structural level of modeling. So what I have written here, I have taken two variables, input variables A and B, output variables as Y, which is a vector. The size is from 6 to 0. 6 is your MSB, 0 is LSB. That means Y6 represents the MSB, Y0 represents LSB. What is this MSB and LSB? We will understand in the graph. Next, coming to the code, this is the area where we have to write our code. So first what I have written, not G1 Y0 comma A. So here Y0 is the output, A is the input. So output will be inversion of A or not of A. In the second is a AND gate. Here Y1 is your output, A and B is your input. So output will be Y1 will be equal to A into B. Third OR gate, which is represent G3. Here the output is Y2, input is A and B. So Y2 will be equal to A or B. Then coming to the NAND gate, here the output is Y3, input is AB. So Y3 will be equal to A into B bar. Then next NOR gate output is Y4, input is AB. Y4 will be equal to A plus B whole bar. Then XOR gate, Y5 is the output, which is equal to A XOR B. Then last one XNOR gate, which is equal to output is equal to Y6, input is A and B. So Y6 is equal to A XNOR B. And we already know that what are the different logics, how we'll get from A and B to different outputs like AND output, NAND output, NOR output, like that. So this is the code. It will start with module and it will end with AND module. Okay. Now with respect to this one, I have written the test bench. So now this is the test bench I have written. So first let us delete this two. So this is logic gates S. So here I have given the module name logic gates S, structural level. So this is logic gates S. So in the already I have discussed about this test bench how to write. So module logic gates, here we will declare the input variables A underscore T, B underscore T. Then output variables Y underscore T, which is a OR data type, input is a register data type. Then we have to instantiate the module. This logic gates underscore S is the module. We are passing the data A underscore T to the A variable of the module, B underscore T to the B of the logic gates module, Y underscore T, which is the output, passed to Y output terminal of the logic gates module. Now I have initialized the value of the input variables. A underscore T0, B underscore T0, because here two inputs, so there will be four different combination: 0 0, 0 1, 1 0, 1 1. Okay, I have taken another 1 0, or you can take it or you can exclude this one. Then after that we have to finish our test bench. So after 10 nanoseconds dollar finish, it will finish. Now see in the left side in the design source, if you'll see here, different design source are there: logic gates underscore B, logic gates underscore D, logic gates underscore S. But first I have to do the execution with respect to logic gates underscore S. Then what I will do, I have to right click this one, then I have to set as top. So by making this module as a top module, this symbol you are seeing, this is coming from a middle one to lower one. Now coming to the test bench, you can see the logic gates TB is there. Here all those logic modules are there. Since I have not saved the test bench, so it is showing all three. If you go to the test bench, I will save it. Now after saving, you can see that under this test bench, if you click here, only logic gates underscore S is there. That means this test bench is designed only for this module, logic gates underscore S. Okay. So next what we'll do, we'll run simulation. So this is the test bench code. This is the logic gates underscore S. This is the module design source. Now we'll run simulation. Now this is the graph. Then we have to zoom, click on zoom fit. Then this plus is there. We can click here to see all those waveforms. Now see here, if I am giving 1 1, so what is my y6? So now if I am not extending this one, then you can see that it is representing 6 to 0. So this first one is your representing y6, then y5 4 3 2 1 0. So this is your MSB, this is your LSB. Now in this binary representation of this y, you can understand that this is the LSB is 0, MSB is 1. So now what is y6? Y6 what it is representing? It is representing the XNOR gate. So now if you want to verify, you will take this value 1 1 I have taken. So for 1 1 XNOR value will be, if both value is same, then XNOR value will be 1. This is showing 1. Then x5 what I have taken? X5 I have taken XOR value. So if both are input are same, A underscore T, B underscore T is same, then XOR value will be 0. So it is coming 0. Okay. Next coming to Y4, Y5, Y3, Y2, Y1, Y0. Now coming to Y0. Y0 I have taken inversion of A. So if A is 1, then it will be 0. Then Y1 I have taken AND gate. So it will be 1 1, then AND gate is 1. Y2 is your OR gate. 1 1 OR gate will be 1. Y3 is NOR gate. Y4 is NAND gate. Both are all are giving correct output. Okay. Now how, you may ask, how this value is coming? So you are seeing this cursor. Wherever the cursor will move, that value it will show. If I am moving the cursor here, it is showing 0 0. Now with respect to 0 0, the values are showing, the output values. Then if I will take this cursor to here, it is showing 0 1. Then with respect to 0 1, what are the outputs it is showing. Similarly, if you will take 1 0 1 0, values are showing. If you will take 1 1 cursor, then with respect to 1 1 it is showing. So this is the graph with respect to the structural level of modeling and test bench. Now let us go to the next, data flow modeling. So this is the data flow modeling I have written here. So see here, module logic gate, logic underscore gates underscore D. So same, I have taken same a b as input variable, y is output variable. Then the difference is that in data flow modeling you have to use the keyword assign. By taking this assign keyword you have to write, and there we have calling the gates, here not calling the gates, we have to write the assign, and the expression how the gates symbols are there, that symbols, by taking the help of that symbols you have to write the expression, and that expression you have to mention and you have to assign to the output. So same thing, y0 I have assigned to not gate, a negation of a, and y1 is a and b, y2 is a or b, assign y3 is inversion of a and b, that means NAND gate, assign y4 is not of a or b, that is NOR gate output, assign y5 is a XOR b, assign y6 is a XNOR b, not XOR XNOR. Okay, now this is the code for all logic gates: AND gate, OR gate, NOT gate, NAND, NOR, XOR and XNOR. And here only the difference is to know whether this code is data flow modeling or other types of modeling, you have to see the keyword assign. If in the Verilog code assign keyword is used, then that is a data flow types of modeling. Now let us go to the test bench. So this is the test bench, same test bench will be there. So now what I will do here, I will same test bench I have to pass. So I'll copy this here. So what is my module name? So this one I will delete. So I'll go to the data flow modeling. What is the module name? This is the module name I have given. I'll just copy this and I will paste in the test bench instantiation code. So remaining will be as it is, whatever we have written. Only the instantiation I have added another module, that is logic underscore gates underscore D. Since both are similar only, this is a structural level of modeling, this is data flow level of modeling. So both have same input and output. It will get easily to pass this inputs to the data flow modeling. Okay, so now what we'll do, we'll go to the simulation and we have to do the simulation. Before that, some changes we have to do here. What is that changes? First thing is test bench we have changed, we have to save it. By saving you will see whether it is saved or not. How can you know? Because by saving I will see that earlier only logic underscore gates underscore s is coming under this logic underscore gates tb. In this test bench only this logic underscore gates underscore s is coming, but now another is added, that is logic underscore gates underscore d. Next what we will do, since this is the test bench, a single test bench, so we don't have to change the top module of the simulation source. Where we have to change? Design source. Now in design source, which one is the top module? Logic underscore gates underscore s is the top module, but I want to simulate the logic underscore gates underscore d, that means data flow types of modeling or data flow modeling code I want to simulate. So I have to select this one, right click, set as top. Then now you can see same test bench, but the design source is a data flow logic gate source. Now you have to do the run simulation, run behavioral simulation. Yes. So command failed. So now we'll see what is the errors we have. Let us see the errors. Okay, there is some errors because We can take the same test bench code, we can pass it, but whenever we are passing the test bench, we can pass only one module at a time. We cannot transmit, or we cannot pass that same input to the all those three or different types of modeling at a time. So what I have done here, in this test bench, I have disabled this one, logic underscore gets s. I have disabled, so only the input is passing to this data flow modeling code or data flow module. So now we'll run simulation. So again, test here, you can click for zoom fit, then click here, you are getting the output. Now you can also verify by taking different input combination. You can verify if in the waveform you are getting confusion or getting some difficulties to verify, then use this cursor, take the cursor. If I am taking here, you can verify from this value. Again, you take the cursor to the next and verify the value. This is 0 1 input, then verify the outputs. Similarly, take this one here, 1 0 input, verify the output like for different gates. Similarly here. Okay, so graph a test bench waveform verification will be same for all, which types of modeling you are doing, whether it is a structural or whether it is a gate level data flow, or it is a behavioral types of modeling. The waveform verification or waveform will be same, because we are taking same test bench, same input test bench. Next we'll go to the last one, that is the behavioral types of modeling. This is the code. You can see the difference is that in the behavioral types of modeling, we have to use the always block. So in the always block, whatever output you are using, the left side terminals, they must be declared as register. So I have declared this one as a register. You have to remember this, the output terminal of a behavioral types of modeling must be declared as a register. Then we have to write the code always @ a and b. That means this is known as sensitive list. Whenever a and b value is changing, then it will enter inside the always block and it will do the execution. After that, we have to write the code begin. Then y0, y1, y2, these are the outputs of the gate. y0 is the output of NOT gate, so it is not of a. y1 is the output of AND gate, is equal to a and b. y2 is the output of OR gate, equal to a or b. y3 is the output of NAND gate, not of a and b. y4 is the output of NOR gate, not of a or b. y5 is the output of XOR gate, y6 is the output of XNOR gate. Then AND 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 module. Okay, so test bench code will be same. Only the changes we have to do in the test bench, we have to add this module. Okay, this module we have to instantiate here. So what I will write here, then I have to write this. Okay, so okay, for the last one we are getting some errors in the test bench. I told you to make it disable, but we can make it enable. Here the name whatever we are given, we can change it. Earlier I have given this instantiation get name same as this second one, so it is showing errors. Now you can see that I have written, there is no disable, all are enable. These two are given, one is DUT, another is UUT. And here whenever I have run it, I'm getting output. Now see the source, you can understand that this is not the output with respect to behavioral type of modeling. Why? Because in the design source, the top module is logic underscore gates underscore D. It is a data flow code. So to get the output in behavioral types of modeling, we have to make logic gates underscore B as a top module. The input can be passed to all, but whichever is the top module in the design source, that will be simulate. Then what else we have to do? Test bench we have to save. So test bench is saved. All three are, you can see that TUT, DUT, UUT is there. Different names should be there. Now we have to simulate this one. Here you can see this is the output. This output is with respect to the behavioral types of code. Whatever design source you have written in behavioral type, with respect to that, this is the code. Now you may have questions like how can you know this is behavioral, previous one is data flow? So to know that, what do we have to do? We have to change the variable in the test bench code. Since I have taken all test bench as the single test bench for all types of modeling, so here the output also looking like same. Why? Because all are only logic gates. So AND gate, if you are writing in behavioral types of modeling or data flow modeling or structural modeling, the output will be A into B. Only the way you are writing, that is different. Understand? So now you can verify here by taking different input to A underscore T, B underscore T. What are the different outputs? You can verify here. And one thing you always remember, here whatever variables you are writing, the symbols or the names of the variables, that is with respect to the test bench variable declared. It is not with respect to the design source variable. The output is with respect to the design source code, but the variable names is written with respect to the variable declared in the test bench. Okay, thank you.